Hello everyone. This is the fifth lecture of some basic concepts of chemistry, which includes laws of chemical combination. Laws of chemical combination: the combination of elements to form compound is governed by the following five basic laws, which is first, law of conservation of mass, law of definite proportion, and third is law of multiple proportion, fourth is Gay-Lussac's law of gaseous volumes, and fifth is Avogadro's law. Law of conservation of mass. So, law of conservation of mass is the first law of chemical combination, and it states that matter can neither be created nor destroyed, and this law was put forth by Anthony Lavoisier in 1789. एंड ये जो लॉ है इसको परफॉर्म इस कंक्लूजन पे एंटोनी लेवॉइसर ये कंक्लूजन तब निकला उनका जब वो कंबशन रिएक्शंस उन्होंने कराए और उनको स्टडी किया एंड उन्होंने केयरफुली कैलकुलेट किया द अमाउंट ऑफ रिएक्टेंट एंड द अमाउंट ऑफ प्रोडक्ट. So, after observing all those calculations and experimental data, he reached to this conclusion that matter can neither be created nor destroyed. So, moving on to our next law, which is law of definite proportion. This law was given by French chemist Joseph Proust. He stated that a given compound always contains exactly the same proportion of elements by weight. सो ये लॉ ये स्टेट करता है कि चाहे कोई कंपाउंड हम नेचुरली एक्सट्रैक्ट करें या फिर उसको हम लेबोरेटरी में सिंथेसाइज करें, it has always the same number of composition, same composition of elements, and same percentage of elements would be present in both of the compound which is naturally extracted or the other one which is synthesized in laboratory. चाहे कोई कंपाउंड लेबोरेटरी में सिंथेसाइज हुआ हो या वही सेम कंपाउंड नेचर से एक्सट्रैक्टेड हुआ हो, इट हैज़ सेम परसेंटेज ऑफ इट्स एलिमेंट विच आर कॉन्स्टिट्यूटिंग दैट कंपाउंड. सो दिस इज़ द लॉ ऑफ डेफिनेट प्रोपोर्शन. और इन्होंने ये एक्सपेरिमेंट किया था क्यूप्रिक कार्बोनेट के साथ. एक क्यूप्रिक कार्बोनेट जो उन्होंने नेचुरल ओरिजिन से एक्सट्रैक्ट किया था और एक क्यूप्रिक कार्बोनेट जो उन्होंने लेबोरेटरी में सिंथेसाइज किया था. एंड ही फाउंड दैट कि कंपोजिशन ऑफ एलिमेंट्स जो थे वो दोनों में सेम थे इन बोथ ऑफ द सैम्पल्स, विच one is from nature extracted and one is laboratory synthesized. In both of the sample, the composition of elements in that compound is same percentage of copper, oxygen and carbon is present in both the samples in cupric carbonate. So this leads to this law that which states that compound always he stated that a given compound always contains exactly the same proportion of elements by weight. So thus, irrespective of the source, whether it is naturally extracted or laboratory synthesized, a given compound always contains same elements in the same proportion, and the validity of law has been confirmed by various experiments. It is sometimes also referred to as law of definite composition. So moving on to our third law, which is law of multiple proportion, and the law was proposed by Dalton in 1803. According to this law, if two elements can combine to form more than one compound, the masses of one element that combine with the fixed mass of the other element are in the ratio of small whole numbers. So its examples are also given here, that one element is combining in a fixed mass and other element is combining, other element's amount is changing and one element is in a fixed mass. So in that case, the elements which combine with each other are in the ratio of small whole numbers. This is the law of multiple proportion and its examples are water and hydrogen peroxide. So we can see that hydrogen plus oxygen, when they combine it form H2O. So 2 gram of hydrogen plus 16 gram of oxygen, when it combine together form 18 gram of oxygen, while 2 gram of hydrogen combined with, here hydrogen mass is fixed, its amount is fixed, oxygen mass is changing, so it forms H2 O2, which is hydrogen peroxide, 34 gram. When 2 gram of hydrogen two gram of hydrogen combines with 32 gram of oxygen, it forms 34 gram of hydrogen peroxide. So here the mass of hydrogen is fixed, but the mass of oxygen is changing, which leads to the formation of water and hydrogen peroxide. So they are in the ratio of 16:32. Hydrogen mass is fixed while oxygen mass is changed, and so it is in the ratio of 16:32. So it is bearing a simple ratio of 1:2, which is a ratio of small whole numbers. So these are the examples of law of multiple proportion. Moving on to our next law, which is Gay-Lussac's law of gaseous volume. This law was given by Gay-Lussac in 1808, and he observed that when gases combine or are produced in a chemical reaction, they do so in a simple ratio by volume, provided all gases are at same temperature and pressure. According to this law, कोई भी गैस जो कंबाइन हो रही है और या प्रोड्यूस हो रही है इन अ केमिकल रिएक्शन, वो एक सिंपल रेशियो में होती है, उनके जो वॉल्यूम्स होते हैं वो सिंपल रेशियो में होते हैं whenever they are at same temperature and pressure. So example of Gay-Lussac's law of gaseous volume is hydrogen plus oxygen forming water. So 100 ml of hydrogen gas plus 50 ml of oxygen is forming 100 ml of H2O without leaving any unreacted oxygen. So thus the volume of hydrogen and oxygen which combine together, that is 100 ml and 50 ml, bear a simple ratio of 2:1, which is 100:50 is 2:1. So Gay-Lussac's discovery of integer ratio in volume relationship is actually the law of definite proportion by volume. The law of definite proportion as stated earlier was with respect to mass, and the Gay-Lussac's law was explained properly by the work of Avogadro in 1811. So moving on to our next law, which is Avogadro's law. So in 1811, Avogadro proposed that equal volumes of gases at the same temperature and pressure should contain equal number of molecules. सो एवोगेड्रोज लॉ ये स्टेट करता है, Gay-Lussac's लॉ का डिटेल एक्सप्लेनेशन दिया था एवोगेड्रो ने, एंड एवोगेड्रो लॉ स्टेट्स दैट इक्वल वॉल्यूम्स ऑफ गैसेस अगर सेम टेम्परेचर और प्रेशर में रखी गई हैं तो उनमें इक्वल नंबर ऑफ मॉलिक्यूल्स होने चाहिए. Avogadro made a distinction between atoms and molecules, which is quite understandable in the present times. And if we consider again the reaction of hydrogen and oxygen to produce water, we see that two volumes of hydrogen combine with one volume of oxygen to give two volumes of water without leaving any unreacted oxygen. So this is the explanation of Gay-Lussac's law of gaseous volume, which is explained in detail by Avogadro's law. It is stating that if अगर दो वॉल्यूम्स ऑफ हाइड्रोजन रिएक्ट हो रही हैं, कंबाइन कर रही हैं वन वॉल्यूम ऑफ ऑक्सीजन के साथ, तो वो दो वॉल्यूम्स ऑफ वाटर प्रोड्यूस कर रही हैं विदाउट लीविंग एनी अनरिएक्टेड ऑक्सीजन. So that is why that ratio is taken to form water. 100 ml of hydrogen and 50 ml of oxygen to form 100 ml of water without leaving any unreacted oxygen. So in fact, Avogadro could explain the above result by considering the molecules to be polyatomic. If hydrogen and oxygen were considered as diatomic as recognized now, then the above results are easily understandable. However, Dalton and others believed at that time that atoms of the same kind cannot combine, and molecules of oxygen or hydrogen containing two atoms did not exist. Avogadro's proposal was published in the French journal De Physique. In spite of being correct, it did not gain much support. After about 50 years, in 1860, first international conference on chemistry was held in Karlsruhe, Germany, to resolve various ideas. And at the meeting, Stanislaw Canizaro presented a sketch of a course of chemical philosophy which emphasized the importance of Avogadro's work. एवोगेड्रो ने उस टाइम पे ये जो थ्योरी एक्सप्लेन करी थी, सो ही कंसिडर्ड दीज मॉलिक्यूल एज पॉलीएटॉमिक. हाइड्रोजन एंड ऑक्सीजन वर नॉट कंसिडर्ड एज डायटोमिक, जो आज के समय में हम उसे डायटोमिक कंसिडर करते हैं. डायटोमिक अगर उस समय पे कंसिडर करते तो ये थ्योरी और भी आसानी से एक्सप्लेन हो सकती थी. बट ड्यूरिंग दैट टाइम डेल्टन एंड अदर साइंटिस्ट ने ये बिलीव किया कि कोई भी दो एटम्स जो सेम है वो मॉलिक्यूल फॉर्म नहीं कर सकते हैं. बट राइट नाउ it is it is very well discovered that दो एटम्स कंबाइन कर सकते हैं एंड मॉलिक्यूल्स फॉर्म कर सकते हैं एंड डायटोमिक फॉर्म में एग्जिस्ट हो सकते हैं. सो एवोगेड्रोस की ये जो थ्योरी थी वो प्रपोजल पब्लिश हुआ था जर्नल डे फिजिड्यू में. एंड देन इसकी थ्योरी एवोगेड्रोस लॉ वाज करेक्ट बट इट डिड नॉट गेन दैट मच सपोर्ट. एंड आफ्टर 50 ईयर्स 1860 में फर्स्ट इंटरनेशनल कॉन्फ्रेंस हुई केमिस्ट्री में, जो कार्ल्सरूहे जर्मनी में हुई टू रिजॉल्व वेरियस आइडियाज. और उस मीटिंग में Stanislaw Canizaro presented a sketch of course chemical philosophy which emphasized the importance of Avogadro's law. So after 50 years, Avogadro got recognition, a proper recognition for his discovery or work, recognition for his theory which is almost correct. So it also took 50 years to get his work's recognition. So in this way, Avogadro's law came out to be the impactful one. So this is it for today's lecture. Thank you everyone.